Let's present our report with the topic the virtual reality simulator development for dental students training, a pilot study. Structure of presentation. Aim and objective of research. Selected hardware and limitations. Algorithms of surface deformation. Improved marching cubes. Stages of development of a 2 drilling simulation. Dental drill simulation. The development of VR scene for dentist office simulation. The development of VR scene for dentist office simulation. VR environment interface. Satisfaction questionnaire of VR environment. The augmented and virtual reality are considered as the key technologies in education of the 21st century and are used to study complex abstractions. It sounds especially actual as the technologies provided effective tools for the remote students learning in period of pandemic COVID-19. The technologies of the augmented and virtual reality have a special role in medical education as an additional tool for training professional skills in preclinical practice. The aim of our research is to develop a virtual reality simulator for the teaching of dental students. To implement the simulator aimed at dental studies teaching, the Oculus Quest 2 VR headset was chosen by author as the hardware and Unity 3D as the software. The technologies used to develop the simulator can be expanded and integrated to develop software solutions applicable to new headsets and for different learning purposes. The project is being developed for a specific platform, a standalone virtual reality headset Oculus Quest 2. This modern model boasts the high-resolution displays and its own graphical processor, which allows it to work autonomously without connecting to a computer. It's important for the equipment that can be used in educational process, but it entails a number of limitations, such as reduced performance. Considering the specificity of the device, it's necessary to develop an optimized algorithm for deforming the tooth surface using drill simulation. To do this, the most popular approaches for real-time surface deformation were studied. Constructive solid geometry has extremely high accuracy, but lack of open stable solutions and not suitable for working with soft shapes. Dual contouring of Hermite data has high accuracy and can work with any shape, but requires a lot of computing resources to update shape. Marching cubes has the best combination of performance and accuracy and easy to upgrade and optimize. The algorithm that was ultimately chosen is marching cubes. This algorithm is most often used in computer games as a method of procedural terrain generation using multidimensional noises, but due to its high performance, it was also used in this project. The algorithm requires a voxel representation of the model. For this, voxelizer algorithms are used, the task of which is to represent the model as a three-dimensional array, each element of which indicates whether a substance is present in a particular three-dimensional pixel, that is, a voxel, or not. The algorithm can be improved if you store not just a Boolean flag of the presence of a substance in a voxel, but some number that indicates the intensity of the presence or density of the substance. This allows for smoother transition between adjacent voxels. Also, in addition to the density map, you can use a material map. Thus, it's possible to distinguish between a healthy breed of tooth and those affected by caries to varying degrees. The main stages of the development of tooth drilling simulation are considered. They include voxalization, marching cubes algorithm, collision detection, and detection of penetration depth of the dental drill. Before starting to work with marching cubes algorithm, the original 3D model must be voxelized and is converted to scalar density grid. In addition to the density grid, a material map is also needed. The material map can also store meta-information about mesh editing under the influence of the drill for further analysis of the simulation results. The approaches to the detection of penetration depths of dental drill have an important role to simulate tooth drilling. We consider different approaches, such as the approach based on the sum of resistance forces at all boundary boxes of the drill moving velocity, and material removing velocity. Next approach is based on the proportional dependence of the reaction force and penetration depth of dental drill and proposed force filtering methods for possibility of large magnitude control of the force. Final approach based on the evaluation of the penetration force by integrating the unit force acting on the outer voxel of the tool. In our research, we decided to use the method built into the Unity. This approach uses collider and rigid body component to simulate collisions between physical objects. When the drill removes tooth material, the collider of the area affected by the drill is rebuilt. To avoid penetration of the drill through the surface of the tooth, the velocity tracking method is used to move it. For the creation of the realistic immersive virtual environment, the framework Unity XR and single-pass anticipatory rendering engine Universal Render Pipeline were used. Since the resources of an autonomous VR device are very limited, the 3D models on the scene need to be simplified. For the smoothest display, it's recommended to keep the number of vertices on the scene in a volume of less than 300,000. To do this, you can perform the procedure of decimate polygons using different algorithms presented in graphical editors. One of the algorithms used from the Blender editor merged polygons if the difference between their normal planes was less than a specified threshold. Wearing VR headset Oculus Quest 2, the students are transported to a virtual dentist office and can interact with virtual patient's mouth and dentist tools, doing a dental procedure with simulation of tooth drilling. The scene has been designed so that the operator does not have to move around using controllers. All necessary movements can be performed in a real room. Since the headset is autonomous, it does not restrict the operator's movement and turns, and the sensors have no blind spots. Nevertheless, if the dimensions of the real room do not allow this, the ability to move with the help of controllers is provided. There are interactive instruments on the scene, the main of which is a drill. Taking the drill in hand, you can drill the tooth of the patient, which is located on the dental chair. The keys on the controller allow you to put the drill into working state and change modes. During operation, the controller vibrates at different intensities, creating the feeling of a real tool. After working with the tool is finished, the operator can return it to the tool shelf. Another equally important part of the simulator is the user-friendly interface, which is designed as a window system. The user can open the quick menu by pressing a key on the controller and select the window type to be placed in the scene space. Windows serve different purposes. Some of them are informative, such as image gallery and tool status window, and some of them control the simulator, such as settings window. In the example shown, the user opens the image gallery window. Placed window can be moved using a grab gesture. With the help of a laser pointer that appears automatically, user can control the elements of the window. Unfortunately, during the pandemic period, the experimental part was restricted. 2 experts and 3 students from the Faculty of Dentistry at the Vernadsky Crimean Federal University were participated in the testing of pilot version of VR simulator in dental education. They evaluated the realism of the tooth 3D model drilling simulation and the realism of VR scene of dentist office simulation based on questionnaire demonstrated in table. The results of VR environment satisfaction are presented below. The evaluation of the realism of the tool 3D model drilling simulation. 2 experts noted that 3D model of tools had acceptable quality. 3 students noted the usefulness of 3D model of tools, possibilities to export tools from different views, and capacities to get first useful experience of tooth drilling. The evaluation of the realism of VR scene for dentist office simulation. 2 experts and 1 student noted that VR scene was enough realistic. 2 students noted that they will need some time to adopt and immerse in virtual environment, and noted some differences of illumination compared to the real dentist's office. All participants noted that such virtual experience was useful as an additional tool to improve quality of education, and could be considered as one kind of tool in special condition, but never couldn't replace real practice and could become a powerful competitor for physical templates usage in dental education. The Oculus Quest 2 virtual reality dental training simulator is capable of simulating the visual experience in the simulation process. Further improvements of this simulator will be aimed at recreating tactile sensations and feedback. The VR simulator can be used in the educational process by dental students at the stage of acquiring primary skills in tooth drilling with immersion in the virtual environment. Testing of the VR simulator on the pilot study has shown promising results in the field of practical skills improvements on the training of dental students in preclinical conditions. In the future, we'll plan to expand the number of participants of our questionnaire to research the satisfaction of our simulator in dentistry education for a more relevant sample. Thanks for attention.